Welcome to Michigan Minds Podcast, where we explore the wealth of knowledge from faculty experts at the University of Michigan. I'm Kim Shine, a senior public relations representative for Michigan News, and I'm excited to dive into today's topic, the role of pharmacists and medicinal chemists in species conservation. Tim Cernak, an assistant professor of medicinal chemistry in the College of Pharmacy and an assistant professor of chemistry in the College of Literature, Science, and the Arts, his mission is to see pharmacists and medicinal chemists on the front line of species conservation. Hi, Tim. Welcome.
Thank you, Kim. Thanks so much for the opportunity.
I'm excited for you to share with the audience your dream of seeing medicinal chemists and pharmacists be recognized as key players in species conservation. So there's so much going on in your lab.
We're super motivated to get into this space that is new and scientifically exciting, but we feel a really strong sense of purpose with this work. Medicine is really advanced right now. You can treat any disease. And yet, if we look around us, there's disease everywhere. In humans, of course, but in other species, there's a lot of disease that is neglected, I guess. The extinction's happening all around us, and as someone who's dedicated his career to improving health, not want to play a role in changing the course of health in the wild. We recently have imagined a future where all these tools could be used to improve any type of health, human health, plant health, animal health.
What is going wrong now when it comes to pharmaceuticals or medicinal chemistry, when it comes to species preservation, and I guess what is going right?
We're at a turning point right now in medicine. This is a golden era for medicine right now. Things that was science fiction when I was a kid are all wholly realized. If you were to watch episodes of Star Trek, they had like the, medical devices where it would like diagnose disease and treat it rapidly. We're right on the cusp of that happening. Case in point, COVID, right? It's like extinction level event for humans, all hands on deck, get a medicinal intervention now. And we did it. Within a year, there was a vaccine, and then not quite a year later, there was a new drug, Paxlovid, for this, emergent alien disease. That success rode on many generations of technology that accelerated the invention of medicine. And we've gone so much further in the years since the outbreak of COVID. Medicines are much easier to invent today than they were in 2020. I don't want to make it sound easy, but, we're all driving towards this accelerated medicinal invention. Tools like ChatGPT and other types of AI are making things easier. There is more and more available data. And so it's not hard to imagine a future where, at least in terms of a small molecule medicine, you could have one for a new disease in, months, maybe. We're not there quite yet, but it's not hard to imagine that could be coming. Prove its safety. It's harder to imagine how we're going to streamline that, but it will be streamlined. But the notion that, a new disease comes out, never been seen before, and we could tackle it with a small molecule medicine, that process is going to be shrunk considerably over the next decade. And when that happens, we could imagine a situation where we could look beyond humans as patients in need of medicine. And it just so happens that, we don't really have 10 years to wait, right? So there are many endangered animals and plants that may not be here 10 years from now. The akikiki is a Hawaiian songbird, cute little guy, beautiful song. And in 2023, there were 5 of them left in the wild. They may be extinct right now. And the driver is malaria, avian malaria. We have drugs for malaria, but we don't know how to treat a songbird with those drugs. And so this is the question that we're asking. How could you achieve that? How could you intervene as we would in a human health situation? This is the question that we're asking.
And you're doing some of that intervention, correct, with various species?
The type of work that we're piloting now, it's new for us, and there have been versions of this that have been explored in veterinary medicine for some time. A disconnect that I see is the resources that I have witnessed in human medicine. My background is having worked in big pharma. I spent 8 years in big pharma. I started a company that we were able to get a medicine into first in human in under 2 years from the start of the company. So AI can accelerate these things, but the resources that were available to me to pull that off, both at Iambic and at Merck, enabled that acceleration. When I look at the front edges of veterinary medicine attempting to work in the wild, it's almost all done on a volunteer basis. And, drugs are typically selected because they're the cheapest ones that are available. And there's obvious reasons that's the current model and that's how it is, but that's not how we would intervene in many human health situations.
Do you see the role of pharmacists or medicinal chemists kind of teaming up with those veterinarians or conservation groups?
We just want to plug in all the modern tools from human medicine into conservation.
Okay.
Right? That in here at the University of Michigan, we have incredible resources for high throughput screening, for high throughput computational docking, and for making new chemicals and formulating them. And so we would love to be able to receive diseased tissue from the wild and screen it in the same way that we would from tissue received from the clinic, from the hospital here. It's a very common workflow to receive a cancer patient's tumor cells and screen our newest drugs against it and understand which ones are most efficacious and also safest for that. Why couldn't we look at a disease that we have tons of drugs for and it's causing extinction of adorable animals out in the wild?
You are doing some of that research, right? Where tissue's coming to your lab and you're able to determine what best treats that tissue in that species.
We're currently working with partners in Florida who receive sea turtles at a relatively high frequency, several turtles a week, riddled with cancer. And so people on the beach notice these turtles and they have tumors all over their body. They can't even see because the tumors have obstructed their vision. The Loggerhead Marine Life Center in Florida is the champions of this intervention. They're veterinary experts where they have the capabilities to take these turtles and treat first with surgery and then occasionally with pharmaceutical intervention using cancer drugs. The problem with standard of care in that situation is that the cancer drug that's indicated for this application, there's only one that's shown efficacy in turtles. In humans is contraindicated with scuba diving. So it causes a lung inflammation as the side effect of this drug. And if you were a human taking this drug, the doctor would say you can't go scuba diving for at least a year. That's kind of a bummer of a recommendation for a sea turtle, right? And so we're living in a golden era of cancer medicine. It is incredible what we have realized in the past decade in terms of treating cancer. And so why wouldn't we pull some of these resources into this situation, which is now the primary stranding cause of sea turtles in Florida?
I did want you to touch on a sampling of species you've worked with or actually studied in the lab.
We got our start in hemlock trees. Hemlocks are the only tree that grows in the northeastern United States that can grow in a shaded environment, and they're also evergreen. And so that's really critical to the ecosystem if you think about it, because our forests here, lovely forests in Michigan, you have like this coverage of maple and oak leaves, right? And then what happens in winter? They all fall down. And so because the hemlock can grow in the shade, it can grow under those trees. And then when all those trees have lost their leaves, now there's this forest ecosystem that provides shelter all winter long. And it's really critical to keeping streams cold. These trees love to grow on the edges of streams in riparian areas. And so they're critical for trout breeding. Trout will breed in the shadows of hemlock trees. And so like all this interconnective. Wow. And I called some local garden centers and they said, well, we can't sell you hemlock trees. We no longer sell them in the state of Michigan because of this invasive insect called the hemlock woolly delegate. And so this insect has devastated the northeastern hemlock forest. And so at this point, we receive hundreds of samples of hemlock trees every month. They are collected from all across the northeastern United States. Some of them are believed to be resistant to the hemlock woolly delegate. There's one tree that grows healthily amongst many dead trees, and it has been cloned and distributed throughout the United States. And so from different growing environments, we receive samples of this. At the University of Connecticut, they do the genotyping, and here we do the phenotyping. We do a deep chemical analysis on this, on each sample that we receive. Both in my labs, we look at various terpenes and sugars, and in the labs of Professor Roland Kirsten here at the University of Michigan College of Pharmacy, he looks at some of the other water-soluble components, or he uses a technique called untargeted metabolomics, where we look at all the chemicals that come out. And so at this point, we just have a massive amount of data.
When did you start veering into animals?
When I learned about sea turtles with cancer. And at that time was working on a company that was inventing cancer medicines. I was like, wow, I know so many options that are available to us. But, I would talk to, I met one veterinarian who was working in sea turtles and asked, well, you've treated with cancer meds, how did you choose them? And they said, well, they're the cheapest ones. And just having come off of, like 2021 was such a big year for biotech. There was so much venture capital investment. There was a lot of money that was available. And I witnessed that. And it was just kind of shocking to see this disconnect, where all these resources are available to invent new medicines, because we have to cure cancer, and we can and we will. And let's just try to get to the turtle who's dying with cancer as quickly as we can.
These relationships or collaborations that you've built and that are ongoing with conservationists and various groups, this is very casual, really. You hear about a problem and you reach out personally, it sounds like.
100%. Right now we're looking for, anywhere where disease is driving population declines in the wild, you have our attention. And so we have a massive effort with Tim James here at the University of Michigan and Brian Gratwick at the Smithsonian Institute, the Smithsonian Zoo, working on Panamanian golden frogs. And the most significant extinction event happening on our planet right now is a fungal infection in amphibians. We've lost perhaps 400 species of amphibians in the past 20 years. And antifungal drugs work, but there's a lot of challenges associated with that. We're looking at amphibians that are so tiny they could sit on your thumbnail, little mantella frogs. They're adorable. All the way up to Japanese giant salamanders, which can weigh 75 pounds. And is imagining how we could apply this in zoos and in wildlife rehabilitation centers, but then rewilding and actually doing that in Panama or in an actual ecosystem. How do you pull that off? We don't know. We're working on this. Our mission as establishing a role for chemists, and it's difficult to articulate what the role for a chemist is in conservation. I'm an environmentalist. I just love nature. This was the primary motivation in my departure from the pharmaceutical industry, is I just couldn't see how I could apply my talents to nature, to biodiversity preservation. One story I think is really intriguing. It's chemistry at its heart. It was bald eagles and peregrine falcons nearly went extinct because of DDT. Mm-hmm. And so someone had to draw the link between their eggs were coming out malformed or not with a proper shell. And so someone had to figure out the link between DDT and that effect in birds, and recognize that if we intervene and we say we're not going to release DDT into the environment, then we could save bald eagles. And thank heavens we did, right? I mean, bald eagles are awesome. They're our national symbol. So just thinking of all the chemistry that needed to happen to make that regulatory change, I think that, this idea of identify a disease situation, receive tissues, put it through all of the workflows that we would do if it were diseased tissue received from a human patient in the hospital, screen it against drugs, virtually or in vitro, and identify what's the best medicine for this exact situation.
Can you summarize generally what a medicinal chemist does and tell us about the research and discoveries happening in your lab?
So a medicinal chemist invents medicine. We're at the inventing step. And so understanding the disease and what is needed at a molecular level, and then bringing that molecule into existence using synthesis, sticking it together. Lego is my favorite analogy. So we have a big box of Lego, and we're trying to make shapes that stick to the protein that's causing disease. Science has been operating for probably 150 years or maybe 200 years. There's a rich history that we can pull from now. And the rules of bond making, they line up so nicely for machine learning and artificial intelligence. And so there's all kinds of challenges to applying AI for medicinal chemistry, but it is totally happening. So we dream of a future where medicines can be invented at a rapid pace. Even when I left the pharmaceutical industry in 2018, it's a completely different game right now. When there are 5 specimens of the akakiki left and it's dying of malaria, avian malaria, so it's not 100% certain that our malaria drugs would work in this situation, but it's just intriguing to think about. As someone who invents medicine to improve health, how do you think about that situation?
I really appreciate your talking to us about all of this, and I wish you the best in reaching more species, and thank you for what you do.
Thank you so much, Kim.
Thank you for listening to this episode of Michigan Minds, produced by Michigan News, a division of the university's Office of the Vice President for Communications.